Well, hello and welcome YouTube. Mr. Robinson back here with a brand new exciting video. Last one for the week here. It's going to be on quadratic factorization one more time, but the advanced version. Now, there is more than one way to do quadratic factorization in this form. Some teachers teach what's called factoring by grouping. Some teachers use this kind of generic rectangle method, and I have videos that refer to those two things right there. If you want to look in the description section of this particular video, you can find a link to that. It's a lot more exhaustive because I talk about factoring by grouping, generic rectangle factorization, and mental factoring. Here I'm going to talk about mental factoring as well, but I'm going to try and go with it as quick as possible. Now, I got these problems from a book. I haven't done the problems yet. It's important that I haven't done it yet so that what I do is going to be like what you would do when it comes to this. There's some trial and error involved, and you're going to see that in the rule. So let's go straight to it right now. Quadratic factorization rule 2. Last one was rule 1. If you want to watch that video, it's a very basic form with x squared plus bx plus c. This is now ax squared plus bx plus c. I'm referring to a possibly not being positive 1, which means you got to do more to your factoring. Okay, in a factorable quadratic trinomial, ax squared plus bx plus c, here's the strategy. You're going to seek two factors of a, this quadratic coefficient, and two factors of c, such that when expressed as a product of two binomials, like this look right here, you can distribute the middle terms to become b. Some trial and errors involved. And I know that sounds a little tricky. I'm going to kind of get to what we do here. I got to use the examples to play with it. First one's not a real one. First one as a greatest common factor. You'll see what I mean with it in a moment. But there it is. So one minor note, if a greatest common factor exists, like in blue here, factor it out first, and it may come to be your polynomial will have a leading coefficient of 1, just like the quadratic factorization rule 1. This should say QFR1, not QRF1. QFR1. Go to the previous video if you want to see more to that, because we're going to do one here in just a moment. Yeah, let me actually start with this problem, and then we'll go to the next three. So this first example here, there's a common factor of 3, and if you seek that out first, I promise you it's going to make this problem so much easier. If we factor out that 3 first, now we got a 1x squared problem, which means we can do this just as basically as we did the previous problems. We find out what two numbers multiply to make negative 2 and add to make positive 1. Those numbers are going to be positive 2 and negative 1. Positive 2 and negative 1. And I'm going to kind of go faster on that because I'm not teaching this part again. If you want to find out what two numbers multiply to make positive 2 and add to make negative 1, you're taken care of right there. It's pretty fast. The 2's a prime number, so it makes it pretty easy to do there. The 3 stays on the outside, and I'm good. So I made this problem a lot easier, even though it wasn't 1. And like I said, it's like the last video that I did. I had the last example that was like this. You get one more version of it, but very fast scope. Okay. Now, the next 3 problems that we do, you're going to see, like this green one right here, there is no common I can't factor a 3 out of 5 and negative 2. I can't make this thing a 1. This thing's going to be a lot more difficult. No, I am not finding out which two numbers multiply to make negative 2 and add to make 5. This kind of problem's different. And it has everything to do with this part right here. Distribute the middle terms to become b. What we have to do here in these problems is, first of all, we got to assume that it is factorable. If you're going to do mental factoring, you're going to play under the assumption that it is factorable to play with it the way you want to. Okay. So here's the basic gist. And like I said, for this video, you need to know how to do binomial distribution. We're going to assume this thing is factorable here. So we're going to break it down to look like this. When you do this, remember the FOIL method, or the idea of binomial distribution. The first two numbers that you multiply give you the first term. In this case, I'm going to multiply some n times some n, and I'm going to get 3n squared. Does n times n give you 3n squared? No, n times n gives you n squared. I need to make this give me 3n squared. Now, the good news for 3 is it's a prime number. How do you get 3? You get it with 3 times 1. So if, listen to this carefully, if this is factorable, the only possible way that this will work is if one of these is 3n and the other is n, 1n. 3n times n gives me 3n squared. The rest will have to fall in line here. Okay. Now, those were seeking two factors of a. I actually just found my two factors of a that I'm going to need if this is factorable. 3n and n. Remember, this is a mental factorization. Let me write this so it's a little cleaner. This is a mental factorization tactic here. We're going to make this as best as we can do with some form of trial and error. And I've already pictured in my head now what the answer is, so I'm going to kind of dodge it a little bit to start. You'll see what I mean. So we now got to find factors of c. Now, the good news about c, this negative 2, is it's also a prime number. The only numbers that we can make as factors of 2 are 2 and 1. Okay. Now it's a negative 2. That means it's either a negative 2 and a positive 1 or a positive 2 and a negative 1. Now compared to the last video and this problem here, in the last video I said, does it matter if I put the plus 2 here and the minus 1 here, or the minus 1 and the plus 2? It didn't matter in this case because these were both 1x's. However, it does matter if I just put plus 2 minus 1 here, even if these were the correct plus 2 and minus 1, maybe they're not in the right spot. Here's where I do the thing about distributing the middle terms. Remember, 2 times negative 1 is negative 2. That would take care of that here. But I need to get 5n. I need to multiply my middle terms in my distribution to give me 5n. And here's what I would do. Remember, 3n times n is 3n squared. 2 times negative 1 is negative 2. But here are the middle terms when you do 3n times negative 1 and 2 times n. Right? Those are the two we didn't do in the FOIL method. We already did this one. We already did this one to get these 3n squared negative 2. But we got to figure out, does this give me 5n? When I multiply these out, I do 3n times negative 1. That's negative 3n. And 2 times n is positive 2n. Negative 3n plus 2n is negative 1n. That does not give me negative or positive 5n. Those are not the same thing. That means despite the fact that I have the right numbers that multiply to make this and multiply to make that, and I know this sounds confusing. If this is your first time, I know this sounds confusing. That's why I'm breaking it down very slowly. You're going to have to bear with me on this. That's what I was saying. We seek factors of a and c, but then we got to test out which ones give us a positive 5 when it's multiplied. 3 times negative 1 was negative 3. 2 times 1 was 2. Negative 3 plus 2 was not positive 5. That means this 2 and the negative 1, even though those are the right numbers, they're not in the right spot. And they might not be the right signs. Now let's see what happens if I just do swap the signs. What if I make this a minus 2 and a plus 1? Because remember, that still gives you a negative 2 at the end. Minus 2 plus 1. What will that give me? Let's try that one out. That's going to be 3n, follow the thick red arrows, or the dark red arrows. 3n times 1 is 3n. Negative 2 times n is minus 2n. That's a positive 1n. Okay, maybe it's closer to positive 5, but it's still not the right answer. And you can tell, what was the difference between this one and this one here? It was the same absolute value. This is a positive 1, this is a negative 1, just different signs. So, and that's always going to happen. If all you do is switch the signs in these, but you keep the numbers in the same spot, you're still going to get the same absolute value. So I already knew that that one wasn't going to work either. Clearly something was still off about it. So I got to change the 2 and the 1 when it comes to location. I just got to figure out which signs they're supposed to be when I do them. So let's go ahead and swap it. This time I'm going to put a plus 1 here and a minus 2 here. And again, you can do this mentally. I tend to do it mentally here. And by the way, I don't actually focus on the ends. I'm really looking at 3 times negative 2 and 1 times 1. I know they're the linear terms. I know they'll combine. So I don't need to really say n. And hopefully you're okay with me ignoring saying n the rest of the way. I'm looking for what two numbers when I distribute can add to make 5. So I'm doing 3 times negative 2, that's negative 6, plus 1 times 1. Remember, this is a 1 right here. 1 times 1 is 1. That is negative 5. Negative 5 doesn't seem to be the case either. But, because negative 5 is and positive 5, right? Not the same. But it's almost the same number. It's the same absolute value, but a different sign. This was negative 5. That means we're close. I'm willing to bet that if we swap this to a negative 1 and a positive 2, negative 1 and positive 2, that this will give us our positive 5 that we're looking for. Let's see. 3 times 2 is 6. Negative 1 times 1 is negative 1. 6 minus 1 is 5. Okay, and that ends up being the value there. So 6 and negative 1, excuse me, 3, this is the correct factorization. It gave us a 6n and a negative 1n. Remember, I didn't put the n's, but that's what those are right there. 3n times 2, negative 1 times n. They gave us 5n there. So I played with the factors of a, 3 and 1, the factors of c, 2 and 1. 1 was positive, 1 was negative. We didn't know which. And we had to kind of determine where they place in here to make this factorable. You can double check and distribute it all, but that's the point. We kind of already did. We kind of just did distribute it all. Distribute it all. We know that 3n times n is 3n squared. We know that negative 1 times 2 is negative 2. Now we played with outside and inside to figure out which ones gave us 5n. So we're literally doing reverse distribution here. We're distributing to figure out what it would factor to. We're kind of playing that backwards form. So that's the end goal there. All right, so that's that answer right there. I know that was a longer talk, and these ones still might stay kind of long, but the more you hear it, the more you'll make sense of it. Keep in mind, if you don't prefer the mental factorization, and by and large, even though you're seeing all this writing, this was very mentally factored. If you don't like the mental factorization, look to my other video for the factoring by grouping or the generic rectangle factoring. Even though those might be more foolproof, they're a little more visually aided. Factoring by grouping is probably not one you'll like as much. You might like generic rectangle factoring more, but it still takes some learning. And I promise you this will be faster, mental factoring, if you know how to work this one out as you keep playing with it. It'll definitely help you out. All right, 2 more problems here and then we'll be done. Negative 4c squared plus 19c plus 5. First thing I'm going to do is find the greatest common factor. Now, 4 can't divide, you can't divide 4 out of 19 and 5. I get that. But we don't want a leading term of negative 1. Just trust me when I say you don't want a negative leading term. Trust me when I say you don't. So I'm going to begin by factoring a negative 1 out of this thing here. I'm just going to write the negative on the outside. And inside I'm going to have 4c squared minus 19c minus 5. So I have now factored a negative outside of it. Now I have a positive leading term. It will just be easier. Trust me. I can't explain why too much. I know that this is when it gets difficult if you don't otherwise. This is properly factored and completely factored when you work this out as well. Okay, so what we have to do now is we got to break this thing down into, if it's factorable, it's going to look like this, right? Now, this one's a little bit trickier, not just because of the negative portion right there, but also because 4 is our leading coefficient right here for the quadratic term. We know it's going to be some c times c. What we don't know is, 4 is called a composite number. 4 isn't just 2 times 2, it's also 4 times 1. So the question is, do I write 4c times c? Or do I write 2c times 2c? And this is where you got to play with this thing a little bit. Maybe. I'll drop you a hint. I know it's not 2c times 2c. And here's why. Remember what we're going to be doing with this information. We're going to be picking factors of 5, which are clearly 5 and 1. And, we'll be doing stuff, actually I have negative 5 right here. But we're going to be multiplying this 2c by something and something by this 2c right here. 2 is an even number. You know what happens when you multiply an even by any integer? The result becomes even. An even times an odd is even, and an even times an even is even. Well, what happens? So when I multiply 2 by something, I'm going to make an even number. 2 by something, I'm going to make an even number. What happens when you add 2 even numbers? That result is even. And 19 is an odd number. There's no way I can multiply 2 by something, and add those somethings to get 19, because that result should be even. So I already know it can't be 2 c's right here. So there are ways. I say trial and error. I say, working things out. But if you know your numbers enough, you know how you can avoid having to do extra work for yourself. And look, to be honest, I shouldn't really be looking at this one right now. I keep pointing back to it. I have to look at this one right here. This is what I'm factoring to. So I know it's not going to be 2c and 2c. I'm going to go ahead and create 4c and 1c here. If it's factorable, that's what it'll get down to. Okay. Now, 4 may have been a composite number, but we've already broken it down to what it's got to be, 4c and 1c for what I said. You can play trial and error on the 2c's, and you can figure out it's not going to work. Now, let's try and make factors here that multiplied, factors of negative 5. So 5 and negative 1, negative 5, positive 1, whatever. But we got to multiply the outside and inside and add them to make negative 19. Why don't you think hard about this? Negative 19 is a relatively big number. What would happen if I put the 5 here and the negative 1 here? Something like that. I'm doing 4 times negative 1. I wasted the big number on the negative 1. There's no way these two things will climb up to make negative 19. No way. I got to put the 5 over on this guy over here. The 5 has to go over where it's going to multiply by 4. So move the 5. What if I moved it right over here, plus 5 and minus 1? This feels a little more comfortable to get my negative 19. Now, is this correct? 4 times 5 is 20. Negative 1 times 1 is negative 1. 20 minus 1 is positive 19. Looks like I have something backwards here. The 5's in the right spot, though. I'm multiplying it by 4, so the 5's in the right spot. Now I just got to get, let's switch these signs here. -5 and +1. +1, -5. 4 times -5 is -20. 1 times 1 is 1. -20 plus 1 is -19. Remember, I'm assuming these are C's. 20C, 1C, 19C, things like that. I got that. But this is the correct factorization right here. Remember, the negative's on the outside, not affecting when I distribute all this stuff on the inside, but it still stays on the outside when I'm done and when I'm factored. So that's the end result right there, the opposite of the quantity 4C plus 1 times 1C minus 5. And again, this 1 doesn't have to be here. It can just be C minus 5 and you're good, but that's the end result. All right, so, it takes a little bit to do some of these things, a lot of trial and error here. I have a lot of support practice videos for you to try. I know it takes up your time, but it's a part of the stuff for you to try if you want to make sure you do this successfully. A lot of trial and error involved. Let's see how we do for the last one. Okay, the last one here, much bigger numbers, kind of scary to play with sometimes, I understand it, but let's go and check it out. First things first, I can see that all these numbers are even. I want to factor out a 2. I want to make this a little easier for myself. Let's factor a 2 out of every single term, and I'm left with 15w squared plus 1w minus 28. Okay, that's as much as I can factor that inside part. It's better, and I promise you it's a lot better that you did this right here. It saves you a lot of headache. However, we still have some work to do. And like I said, I haven't done this problem before, so I don't know exactly what it is. I'll tell you my process, but let's work it out. All right, 2, it's going to multiply by something that's factored here. We know w's are going to exist inside here to make w squared, but how do we make 15w squared? It's either going to be like 5 and 3, 5 times 3 is 15, or like 15 and 1. It's a composite number. You have to check a lot. And 28's no crapshoot either, because 28, what are factors of 28? You got 28 and 1. You have 14 and 2. You have 7 and 4. Am I missing any? That might be it. I think that's it. So you got to play with some of these here. I like to start in the middle. It's just me. I think I can multiply. I don't want to do double-digit multiplication and such. I kind of like to start in the middle. So look, I can't guarantee this is going to be right or wrong. I'm just telling you right now. So I got 5, and I'm gonna try 5 and 3 here, and I'm gonna test out 7 and 4 somehow. Now notice how your 28's negative. That means 1 has to be positive, 1 has to be negative here. So let's try -7, +4. And wow, I think I got really close to the answer here. And I'm telling you, this is my first time trying, and I think I lucked out. But I like to try the kind of middle numbers first, the numbers that I can multiply faster. So what am I trying to multiply? 5 times 4 and -7 times 3. 5 times 4 and -7 times 3. 5 times 4 is 20. -7 times 3 is -21. 20 minus 21 is -1. What do we need? We need a positive 1. We need a positive 1, so we're really close. What did I say we have to alter at this point here? At this point, all we have to alter, this should be a +7, this should be a -4, and then we're actually done with that one. Like I said, you can land on luck. I don't know if it does tend to be that the kind of smaller numbers are better ones to choose to start with, but 5 times -4 is -20, 7 times 3 is positive 21. That gives you that positive 1w that we're looking for. This one ends up being the answer here. There could have been a lot of different tests for this one, guys. For the sake of video time, I'm not going to write them all down. But consider all the different tests we could have done here. With just 5w and 3w, I just tested -7, +4, +7, -4. I could have also had +4, -7, -4, +7. And then with 5 and 3, I could also test +14, -2, -14, +2. +2, -14, -2, +14. See, and then I can try 28 and 1. +28, +28, -1, -28, +1, +1, -28, -1, +28. And then I check 15 and 1. So there are a lot of trials. The fact that I got it on kind of 1.5 tries, like the first try really helped me figure out the second try was going to work, was dandy. And I don't know, maybe I did luck out. I'm not really sure. Just remember that even odd stuff I talked about, though. I knew that 14 and 2 wouldn't work because they're both evens, and when we multiply, you make evens, and 1's an odd number, and all this jazz. It wouldn't have worked out. I would have scrapped this pretty immediately. 28, I just feel like 28's too big of a number. Remember what happened with this like 4 and this 5? It made for really big numbers there. So that's why, again, I like to lean toward the middle a little bit more there. So anyway, 2 stays on the outside. I'm good there. All right, I'm hitting 20 minutes, so that'll be it here, guys. This is a little more advanced, I understand, a little more complicated. Definitely get a lot of practice in here, of a lot more example practice problems online. I'll link you to some videos. Good luck. Take care.